I am in P. Isra Assistant Professor, Department of Civil Engineering, Rohini College of Engineering and Technology. Today topic is design of reinforced concrete solid slab bridge. So problem design and draw the RC solid slab bridge for a national highway with the consideration of following data. Designed for two lane 7.5-meter width and with 1 meter footpath on both sides. The clear span is equal to 5 meter, bearing code 70 mm, width of bearing 0.4 meter. Use M25 grade concrete and Fe 415 grade steel. And loading IRC class AA tracked vehicle. Just to write the given data, the two line is equal to 7.5 meter, the clear span is equal to 5 meter, bearing code is equal to 70 mm, width of bearing is equal to 0.4 meter. And solution, step 1, determine slab depth and effective span. Refer IRC 21 1987 class 303.1 permissible stresses sigma CB 8.3 Newton by mm square and sigma ST 200 Newton by mm square and M is equal to 10, J is equal to 0.9, Q is equal to 1.1. Assume the thickness of solid slab highway bridge at 80 mm per meter of span. The overall slab thickness is equal to 80 into 5 is equal to 400 mm. Let thickness of slab as 400 mm. Assume using 25 mm diameter rebar with a clear cover of 25 mm. Effective depth is equal to 400 minus diameter divided by 2 minus clear cover. So diameter 25 mm. So answer is effective depth answer is 362.5 mm. Width of bearing is equal to 400 mm. Then next find out the effective span. So effective span, first formula is clear span plus effective depth. So clear span 5 meter and effective depth 0.3625. Therefore effective span 5.3625 meter. Then another one formula, the center to center of bearing, therefore 5.5 meter. Take least value of the effective span, 5.3625 meter. Then step 4, dead load calculation. First one, self weight of slab. The self weight of slab is equal to 10 kilonewton per meter square. That is the breadth in the density of concrete. So breadth is 0.4 and density of concrete 25 kilonewton per meter cube. Then load due to the wearing code is equal to wearing code breadth in the density of wearing code concrete. Okay. Therefore answer is 1.54 kilonewton per meter square. The total dead load or self weight is equal to self weight of slab plus load due to wearing code, so 11.54 kilonewton per meter square. Then find out the bending moment for dead load. So 11.54 into 5.3625 the whole square divided by 8. That is the bending moment formula, W square by 8. So answer is 41.5 kilonewton meter. Then step 5, bending moment due to live load. So first one is the impact factor is equal to 25 minus 15 divided by 4 into 5.3625 minus 5. Therefore 23.64% of the impact factor. And assume vehicle is placed symmetrically on the span Therefore effective length of load is equal to 3.6 plus 2 into 0.4 plus 0.07. So effective length of load is equal to 4.56 meter. Then effective width of slab is equal to B is equal to Kx into 1 minus x by L plus Pw. So x is equal to 2.62125 meter. L is equal to 5.3625 meter. So B is equal to 9.5 meter. Therefore B by L is equal to 1.7 meter. So BW 0.85 plus 2 in the wearing cord width. So answer is 0.99 meter. Then K value for B by L is equal to 1.77 for simply supported slab is equal to 2.948. Therefore BE substitute the all value, find out the BE. So B is equal to 3.913 meter. So next, net effective width of dispersion 6.6315 meter, and total factor load for two track with impact is equal to 1298.22 kilonewton. Average factor load intensity is equal to total factor load two track with impact divided by 4.56 into 6.6315. Therefore answer is 42.93 kilonewton per meter square. Then next find out the maximum bending moment for factor live load. So factor for live load M max is equal to, substitute the all value. So M live load is equal to 150.85 kilonewton meter per meter. The total bending moment for live load and dead load is equal to 150.85 plus 41.5. So answer is 192.35 kilonewton meter. Then step 6, CFOs due to IRC class AA loading. The maximum shear while load are subject towards the support. Therefore effective width of displacement is equal to PE is equal to Kx and 1 minus x by L plus Pw. So width of dispersion is equal to answer 6587.5 mm. And average factor load intensity is equal to, first W is equal to answer 43.21 kilonewton per meter square. So find out the factor CFOs VA. So factor CFOs 113.25 kilonewton per meter. Then CS due to the dead load is equal to 11.54 into 5.3625 divided by 2. That is the WL divided by 2. That is the CFOs formula. So answer is 30.94 kilonewton. Total CFOs is equal to 113.26 plus 13.94. So answer is 144.2 kilonewton per meter. Then step 7, design of check slab. So first find out the required effective depth. So required effective depth formula root of m divided by q into b. So m value 150.85 in 10 power 6 divided by q value 1.1, b value 1000, the whole root. So d required is equal to 370.319 mm. So you know that provided effective depth is equal to 400 mm. So check for the required and provided. So the maximum depth is provided, therefore the design is safe. So next to find out the area of steel in tension reinforcement. So area of steel in tension reinforcement m divided by sigma st j into d. Therefore AST is equal to 2311.8 mm square. Then next to find out the spacing of rod. So spacing of rod is equal to small AST into 1000 divided by capital AST. So substitute the all value. spacing of rod is equal to 212.33 mm. So let's provide 25 mm diameter at 200 mm center to center spacing as main reinforcement and 10 mm diameter at 300 mm center to center at the top on both sides. So next, bending moment for distribution reinforcement. So bending moment for distribution reimbursement is equal to 0.3 into live load moment plus 0.2 into dead load moment. So substitute the two value. So find the answer, 53.55 kilonewton meter. So next, find out the effective depth. So effective depth answer 342 mm, and area of steel in tension reimbursement 870 mm square. So spacing of rod small AST divided by capital AST, so into 1000. So only spacing are different, only different for the AST value vary, and diameter of rod is previously 25 mm diameter rod, and this rod is only 16 mm. Okay, then spacing is equal to 231.1 mm. So rounded value 220 mm center to center. So provide 16 mm diameter rod at 220 mm center to center as distribution reinforcement. Next to find out the check for shear. So first to check for shear, find out the maximum factor stress force VU 144.2 kilonewton per meter. Then nominal shear stress dou V is equal to VU divided by B into D. So dou V is equal to 0.397 Newton by mm square, and dou C is equal to 0.4 Newton by mm square. So hence it is safe. Then check for development length at support. So first find out the M1. So M1 is equal to half into Mu. So substitute the value, find out the M1. M1 value is 75.425 kilonewton meter. So next, development length for 25 mm diameter rebar LD is equal to 56 in the diameter of the. The anchorage length of 90-degree bend L0 is equal to 8 in the diameter of the. So 8 in the 25 mm, therefore 200 mm value. So we provide the 25 mm diameter rod, hence it is safe. The next, design of football. So width of football 1 meter as the for a human, and depth of football 0.6 meter. Therefore dead load is equal to length and the depth and density of concrete. So length 1 meter, width 1 meter and depth 0.6 meter, and the density of concrete 24 kilonewton per meter cube. So substitute the three value. The final answer 14.4 kilonewton per meter. Then parapet load, that is the railing, 5 kilonewton per meter, and the live load is 3 kilonewton per meter. So total load is equal to live load plus parapet load plus dead load. So answer is 22.4 kilonewton meter. So next to find out the maximum factor bending moment. W is by 8. So substitute the value. Answer is 120.77 kilonewton meter. Similarly, the bending moment due to vehicle loading. So answer is 90.51 kilonewton meter. The total bending moment is equal to 120.77 plus 90.51. So answer is 211.3 kilonewton meter. Then effective depth is equal to 562.5 mm, and area of steel in tension reinforcement is equal to 2087 mm square. Provide the 4 number of rod 25 mm diameter bar at 4 number of rod 12 mm diameter bar. So stirrups is 10 mm diameter bar and 300 mm center to center spacing. So that is the cross section of deck slab. The below figure, longitudinal section of deck slab. Thank you.